So today, Apposite and Heropa is proud to present the fast and easy way to build web application tests in the cloud. So I'm going to go ahead and get started here. First, I'm going to introduce myself. My name is Cade Nelson. I'm a systems engineer with Apposite. I've been in the TCP/IP acceleration and WAN emulation business for 7 years. Not only am I an employee of Apposite, but before that, I was a user of Apposite. So I've been in the emulation business for 7 years. And I will go ahead and let Jason introduce himself.
Hey everyone, I'm Jason Kinsella. I'm a director at Heropa.
Right. So the agenda for this is to give a quick introduction to Apposite, and then Jason will give a quick introduction to Heropa. And then we're going to go over how combining Apposite and Heropa makes building a test lab in the cloud fast and easy. We'll run through a few different use cases, and then we'll actually do a live demo. Excuse me. So Apposite is the market leader in network emulation. We cover many verticals, including enterprise, development, military, and telecoms. As you can see with some of the logos displayed here, we've worked with most of the industry leaders in these different verticals. Apposite was started 15 years ago in Los Angeles. We have probably closer to 3,000 customers worldwide. So with Apposite, with the Netropy Cloud Edition products, our customers can build a complex network with real-world characteristics inside of AWS. This allows for accurate, cost-effective performance testing. Some of the things we bring to the table are you can build any type of network scenario within a single region of AWS. Even if your product is not a cloud product, you can still use us to create a lab in the cloud and test your non-cloud product there as well. This allows for testing network or WAN functions before deploying to production. You can get accurate measurements of performance or capacity. You can find design flaws or performance bottlenecks. So just some of our solution areas are the satellite, SD-WAN, IoT, storage, video streaming, cloud migration. Pretty much any application that needs networking function, you're probably going to want to use a network emulator to do your testing. And here I'll let Jason jump in for Heropa. Thanks,
Cade. Hi, everyone. As I mentioned, my name is Jason Kinsella, and I'm in charge of product development at Heropa. Heropa is an environment as a service tech startup based in Sydney, Australia. And we simplify the creation, delivery, and management of cloud-based labs for software training, sales demos, cyber ranges, and network emulation and testing. We've been around for almost 10 years, and we started out providing self-service VMware-based training environments for universities and vocational institutes. And about 3 years ago, we migrated to using Amazon Web Services as our infrastructure provider. And more recently this year, last year, we've moved to adding Azure as a provider also. We're an AWS technical partner, and we've recently been invited into a Microsoft Global Accelerator for high growth startups, which we're pretty excited about. So Heropa provides you with an easy to use lab management interface. Our primary focus is to enable smart engineers to leverage the benefits of cloud technologies without having to go back to DevOps school or wrestle with the complexities of Azure and AWS admin portals. So our customers generally have a good grasp of technology. They understand traditional infrastructure deployments. They've used virtualization before. they understand networking, and they can easily deploy virtual machines and install software. But there's three common themes that these engineers struggle with and that Heropa solves for them. The first thing that they tell us is that building test environments in the cloud is time consuming. Even for engineers that know their way around the cloud providers, it can often take hours or even days to get an environment into a state where you can start working on your own software. The second thing they tell us is that the only thing more difficult than spinning up large complex environments in the cloud is remembering to shut down and terminate them before their manager gets the cloud hosting bill. So we solve that. The third thing we hear is that once they have a working environment, they would love to be able to easily create independent copies of that environment, both for themselves and also to share with their wider team and even customers. And in a couple of minutes, I'm going to show you how simple it is in our platform to create a reusable blueprint of a WAN emulation environment. But before that, I'm going to hand back to Cade.
Thanks, Jason. So jumping back in, there's some do's and don'ts when it comes to using the cloud. Excuse me. So some of the do's is you want to avoid the cost of physical infrastructure. Setup time can be minutes or hours rather than days, and you only pay when you're actually using it. So some of the don'ts when it comes to testing in the cloud without emulation is the cloud has too perfect of a network. To get accurate results, cloud providers optimize their networks and run like on a software layer, and they also kill kind of some bad network impairments such as packet duplication, packet loss, duplicate packets, and packet corruption. So AWS gives you a perfect network environment. They do a good job of that. They also add latency because they're running a software layer of their network. So when you do a test, you'll actually get a better network than you should and a little bit more latency than you should. It'll be a little higher than real world conditions. So you'll also incur more cost if you were to spin up, say, if you want to do a test from Japan to Los Angeles or Tokyo to Los Angeles, you spin up an instance in Los Angeles and you spin up an instance in Japan, and then you start running your test. So that data that runs from LA to Japan costs you money. Using us, we can do all that exact same test within a single AWS region. So that's some of the reasons why you don't want to test without using network emulation or using us with Heropa. So some of the other reasons you want to use Apposite and Heropa is you can build everything in a single region. You'll not have to pay for the data transfer, like I just said. You can create your environments in minutes. You can simulate real world network conditions. You can automate everything. And most importantly, you get reliable and accurate results. So here's a use case for you. This is a customer that moves mass amount of data normally over an ocean or a long haul. So moving data over long haul is unreliable and intermittent. Optimizing it is very difficult, especially when you need to build a lab that models after all these different types of client networks. It's very costly, it's complex, it's unreliable. So using Apposite and Heropa together, we can emulate dozens of unique client conditions quickly using the intuitive GUI. We can spin it up within a single region of AWS, minimizing the cost and giving you reliable results. So another use case we have is there's a major network hardware manufacturer company that has a WAN optimization product. This company tried to use open source software and got unreliable, inconsistent results. They needed something accurate and reliable, and it was really hard to demonstrate to the customer how much the WAN optimization product would benefit them. So instead of sending out demo units or trying to use open source software, the manufacturer used Apposite and Heropa, and they would easily spin up potential customer environments, show them the benefits of the WAN optimization right there in minutes, in real time. So not only do they use this for quality assurance, but they also use it for sales demo. So it's really helpful for them. And our last use case, but you know, there's anything that uses networking is a use case, but these are just three real quick, simple use cases. We have application testing using a load balancer, or I'm using a load generator. So basically, how will your web page behave under heavy loads or under imperfect network conditions, or in many situations, how does it work under both a heavy load with not ideal networks connecting? So a good example of this is just recently, Costco had a holiday promotion over Thanksgiving here in the United States. And it drove a lot of traffic to their website, and their website crashed. They didn't do proper load testing. It's estimated they lost around $11 million for just not doing proper load testing, especially using networks. So the reason why I want to point this out is they did load testing, but they didn't add network load testing to it. So for example, a customer, their load testing software would come in and it would take them, you know, maybe 20 seconds to do some sort of transaction. Well, when you have imperfect network conditions, those transactions could sometimes take up to 60 seconds or 120 seconds. And so that's basically giving more time to put load on their server. So they could have done something as simple as this. They could have used Heropa and Apposite and quickly created a load test using a network emulator, or the Netropy Cloud Edition network emulator. So we're going to jump into a demo. I'm going to go ahead and stop sharing and let Jason take over the first part of the demo.
Great, thanks, Cade. Okay, so this is Heropa. Each customer gets their own branded portal. It can be fully white labeled and used as a customer-facing sales enablement and training tool. It's entirely web-based, including access to all of the environments. So I'm now logging in as an administrator. So I jump to the environments. So you can see here a list of active environments. An environment is a collection of virtual machines running in a secure cloud-based sandbox. In AWS, this is a VPC, virtual private cloud, and in Azure, it's a VPN, virtual private network. Environments can be launched in any of 12 AWS locations or 6 Azure locations globally. You would normally choose the closest location for best performance. So the different locations in this list represent a distributed engineering team or global customer training sessions. Each environment is managed as a single unit. It's got a defined lifecycle, access controls, and environments are created from templates. So you'll notice 3 different types of environments: courses, events, and standard environments. We're going to be focusing on standard environments in this webinar, but I'll briefly explain courses and events. Courses are self-paced labs that are published in the end user's library. It consists of an environment template, a lifecycle policy, and optional instructional content. You can invite customers into Heropa and allow them to launch pre-configured environments in a completely automated way. So courses are great for customer training and test drives. This self-service format is the most popular use case for Heropa. And you can see here that Dave Flanagan from Bank of America is 50% through a WAN emulation self-paced course. So that's courses. events. An event is an instructor-led class. It's similar to a course in that it's an end-user focused class. The primary difference is that it's scheduled. So all of the users start at the same time, and the instructor is provided with a virtual classroom view and tools to manage the class. So a standard environment is one that a user internal to your organization launches directly from a template. So a template is short for an environment template, and it's a blueprint for creating environments. Templates contain a defined configuration of VM images, networking, and installed software. So let me show you the process of creating a new template and launching it, and launching an environment from it. And I'm going to use the example of WAN emulation environment. Once you have your base set of templates, these can be cloned and modified and usually form the starting point for new templates. But for this example, I'm going to create a template from scratch. Let's call this WAN template. Vanilla. We're going to run this one in US East region, and I'm going to add in a couple of subnets into here. A management subnet, LAN 1 subnet, LAN 2 subnet, and I'm going to route between subnets. So we now have the basis for our template. Let's add some virtual machines. I'm going to add in a Windows 2019 server and use it as a jump box server. You notice here that when it pulled it from your list of VM images, it's the default size is a 2 gig of RAM. So I'm going to increase the size of this to 4 gig in this specific template. You'll notice here that the credentials are already provided. So when the workspace opens, you're automatically logged in via RDP. Same happens for SSH. You can also run initialization scripts, so you can run a script when the machine is booted up first if you need to add some environment-specific configuration. I'm going to add in, let's add in a couple of Ubuntu boxes. Ubuntu 1. Okay, so I'm going to put this Ubuntu 1 on the LAN 1 subnet. Let's give it an IP address of 20. You can see here as well that on the, for each virtual machine, you can control the inbound and outbound access. I'll add in Ubuntu 2. And we're going to put the Ubuntu 2 box on the VLAN 2. And lastly, we're going to add in the Netropy CE. So this is the Netropy Cloud Edition, which is available with a pay-as-you-go subscription on the AWS Marketplace. So the Netropy box is going to be doing the routing and do WAN emulation between these two Ubuntu boxes. So we're going to give a couple of additional interfaces to the Netropy box. Let's set the IP addresses to be 100, so it's nice and consistent. On the two interfaces that are doing routing, we're ticking this NAT, which disables the source destination check. So anytime you add a routing device into any of the cloud providers, by default, they disable routing on those interfaces. So this disables that source destination check and allows a device to become a routing device. Okay, so we've now got a reusable template that we can spin up an environment from. So let's go ahead and start creating an environment. Let's call this WAN test vanilla, and I'll explain in a couple of minutes why we call it vanilla. I'm creating this environment for Dave Flanagan. He asked me for a vanilla WAN test environment just before the webinar, so it's pretty good timing. The policy controls the life cycle of this environment. You can create any policy that suits your specific use cases. So I'll just select a short access policy for this environment. So what that means is that Dave will have access to this environment for 1 day. It'll be automatically destroyed after 2 days. And if the environment's not being actively used, it will be shut down after 15 minutes to save resources. So I'm now ready to launch the environment, but one thing I'm going to do before I launch this environment is I'm going to add some instructional content. Dave wanted to learn about how to build a WAN emulation environment from scratch. So we've got a piece of content we'll add into his workspace. Heropa has a content authoring tool for creating user manuals. Okay, so one last quick check, and we're ready to launch this environment. It generally takes 2 to 3 minutes to fully deploy an environment. This includes building the VPC, internet gateway, subnets, and security groups, and also the VMs. One thing to notice is that we use fixed IP addresses inside the templates, and this allows you to hard code configurations and launch identical environments from it. You can share environments with other users, invite your customers into an environment. And if you're using Heropa for sales demos and test drives, tracking user sessions is very useful. So I call this environment vanilla because it started out with a collection of basic VM images. Once an environment has launched, the normal workflow would be to open the workspace and complete the configuration, maybe install some software on the Linux server, set up some specific emulation scenarios on the Netropy. And once you're happy with that environment as a starting point for your testing, you can save it as a template in your library. You can see here now that it's completely built. So that took about a little over 60 seconds to fully deploy this environment. So once you're happy with this environment, you can then save this. So once you've gone into the workspace, configured it, you can then save this environment back as a template, and that template can then be published and shared or used to spin up other identical environments. Once you have a running environment, it can easily be modified on the fly. You can add and remove VMs, add subnets, change the firewall configurations. And a new feature we've just released this week is the ability to roll back to a known good state. So if you make a change to the environment and it fails, you can roll back, look at the deployment logs, and try again. So we're going to have a quick look at the workspace, and then I'm going to hand back to Cade. The workspace is where all users spend about 95% of their time. They log into Heropa, launch an environment, and 2 minutes later, they're working on a real-world scenario. We broker all the desktop sessions, RDP, SSH, VNC, through HTTPS. So there's no browser plugins to install or corporate firewall ports to open, which reduces the friction of trying to share an environment with your customers. The panel on the right side is the WAN setup guide we added before launch. And you can include videos and other type of content directly in that panel. Once we detect inactivity in the workspace, the shutdown policy kicks in and all the VMs are automatically stopped. When a user returns to the workspace, Heropa automatically boots the VMs. That's the workspace. So Cade, over to you to show us an example of how the Netropy Cloud Edition can be used in one of these environments.
Great, thanks. Can everyone see my screen okay? All right. So we just saw Jason build an environment that's very similar to the environment I'm about to show you. So he had 2 Ubuntu servers with Netropy in between up in the AWS VPC. So in this demo I'm about to show you, I have a JMeter server with the IP address of 10.0.1.200. And then I have an Apache web server with the IP address of 10.0.2.200. And there's the network emulator in between. So when I run tests, I can actually put network impairments between these two in a single VPC or a single region. So as we see here, we have all our environments. Here's the one that Jason just created us, but I'm going to use this webinar environment right here that I created earlier. As you see here, we have one Windows box, one JMeter server, one Apache server, and the Netropy CE. So I'm just going to launch my workspace. And again, this is all done over HTTP, as Jason explained before. Makes it easy. Doesn't matter if we're in Windows or Unix. And now I'm logged in to my JMeter server. I've also used the Chrome web browser to log into the Netropy that's here. So I'm logged in here and I'm looking at the Netropy here, and I'm also looking at the website that's here. So we see the IP address 10.0.0.100, and we're viewing the Netropy here, and then 10.0.2.200 is the actual web page that is being served up by that server. So the first thing I'm going to do is I'm just going to bring up a ping from the JMeter server to the Apache server that I have running. And we can see that there is no latency here. Now I'm going to come back and configure the Netropy CE network emulator. So the first thing I'm going to do is I'm going to create what we call a path. And this path, this is how we create different types of networks. Now there's the easy way to do it. I can use some of our pre-configured types of networks. For example, I could do a bad Wi-Fi connection. And what happens is when I choose that, it deploys all of the different network impairments, and then I create that path. So now I have a path called Wi-Fi. It's got a little bit of jitter between 40 and 120 milliseconds round trip. It looks like it has an 8 megabit upload and 15 megabit download. And now I want to point my JMeter server to this type of network. So I'll do that by creating an endpoint. So I'm going to call this JMeter load tester. And he's plugged into port 1, and his IP address, I can go back and look here, is 10.0.1.200. And I'm going to assign him to Wi-Fi. So I'm going to create that. And now I'm going to create another. Let me make that bigger. There we go. Now I'll do, and he's plugged into port 2. If we look, this is port 1 on the Netropy, and this is port 2. So the web server was on port 2, and his IP address is 10.0.2.200. And I'm going to create that. So what that means is when I turn on emulation, I should see between 40 to 120 milliseconds of delay. And I'll have 8 megabits in one direction, 15 megabits in the opposite direction. But first, I'm going to show you that there is traffic running through here. This is my ping. I'm looking at my bypass because emulation is not turned on. If I stop this ping, we'll see the traffic stop running through. So that was just my ping traffic. So now when I turn on the emulation, I want you to watch my ping time down here. So right now we're seeing ½ a millisecond of ping time. I'm going to turn on my emulation, and now we see jitter. So this is all within a single AWS region. I have now created a Wi-Fi connection going from my JMeter to my Apache. So if we look, my ping is going from here through the Netropy, hitting the Apache, and coming back, and we're seeing jitter and loss and other network impairments. So now what I'm going to do is I'll just do a quick iPerf test, and let's see how our behavior is. So I'm going to just send some random traffic through here. And I'm not going to do 90 seconds. I'll do 30 seconds. So let's see how my performance is with the JMeter server running through Wi-Fi type connection. So we see we're getting around 10 to 15 megabit throughput. So we're doing pretty good. And we can see here we're getting 15 megabit throughput. So we're seeing pretty good speeds through here, what we should see. There's a little bit of jitter, a little bit of up and down. So the Apache server is just a web page, right? That's what an Apache server is. And this is the web page I'm currently presenting. So another cool thing I'm going to show you is how this works in real time is I'm going to go ahead and turn off emulation. I'm going to go ahead and create another path, and I'll just call this 100 megabit, 100 millisecond. And I'm going to set this to be 100 megabits in both directions. And I'm just going to give 100 millisecond round trip time as well. I'm going to create this path. And now I'm going to move the JMeter over to that path, as well as the Apache server. So it's going to use that. And so what I'm going to do first is I'm going to show you the performance that we're seeing on this web page without emulation. So I'm just going to hit refresh here, and we can see it took 3 milliseconds to load this web page, right? So that's really fast. 3 milliseconds really fast. But let's see what happens when I turn on emulation and I reload this web page. Now we can see that it's 203 milliseconds. So this is what it would look like if we were going through a network that was 100 megabits with 100 milliseconds of latency. So with no latency, it was taking very, very little time, and now we can see that the latency is in there. So that's just one person connecting at a time. So it's very, it's not very much load on the server. So what I'm going to use now is a open source load generator called JMeter, and I've represented 100 users connecting 100 times at once. So this is, a bunch of connections happening at once. So what we'll do is we'll watch the throughput here. I'm going to go ahead. Now this would be 100 users hitting that web page 100 times. Oops, I'm looking at the wrong one. My apologies. There we go. Now we see it. So we can see we're no longer getting the full throughput. We're getting less than the full throughput. And now the test is done. So we can go back, look over throughput for time. And we can see we got a little less than 100 megabits. So let me jump in a little bit more on what the emulator does and some of the functions. So I'm just going to jump in and I'm going to cover the 4 or 5 most important impairments that we offer that most of our customers are interested in. So the easiest way to look at this is we have JMeter and it's plugged into port 1, and then we have Apache that's plugged into port 2. So the JMeter sends its data across this top column here, and first it hits this little group of impairments, and then it hits that impairment, and then it leaves port 2 and hits the destination, and then it returns this way. So the 4 or 5 most important impairments that we have are bandwidth. This is how you throttle the bandwidth. So if I wanted to test, say, a T1 line, or an E1 line, I think is 2.5 in Europe. You can do 2.5 megabits in one direction, and then maybe you have less throughput on the return trip. So you have 1 megabit on the return trip. And then we have our delay. So there's a few different types of delay. You saw me put a constant delay of 50 milliseconds in before. We can also do what's called jitter. So this is where I can set a minimum or a mean. So I can say, oh, the minimum type of, the minimum amount of latency we're gonna have is 50 milliseconds, and the maximum is 75, and we're gonna allow packet reordering. Now, mind you, this is just one direction, so we could actually change, either duplicate the exact same thing on the return trip, or we could even make it worse. Maybe it's 100 to 150 milliseconds on the return path. So this is creating jitter. We have different types of jitter algorithms. We have an exponential where you can set your minimum and then a mean. And then we have normal, where you set your mean and your standard deviation. And then we have scientific notation. Oh, I'm sorry. We have accumulative bursts, which gives you a count of packets, the delay, and then any extra delay. So this represents kind of a network event that happens. Maybe your route moved from one MPLS route to another, or one SD-WAN line to another. So it represents an actual network event. But for now, I'm going to leave that on constant, uniform. So then we have loss. This is how we create packet loss, right? So I can say this is dropping 1 packet out of 100. This is dropping 1 packet out of 1,000. This is dropping 1 packet out of 10,000, 100,000, a million, right? So we can get pretty granular on that. We also have different types of loss models. We have a burst. So this gives you a probability. Okay, 1 out of 100 chance in dropping 1 to 50 packets, right? So this could represent, again, another little network event. Maybe you have a bad switch or a bad router out there, and it's getting buffer overrun. So rather than just dropping 1 packet here and there, how does a switch recover from a buffer overrun? Well, it just drops its buffer. So that means you could drop 1 to 50 packets, or you could drop 1 to 1,000 packets. So you would have a network event. Here we have a periodic. This is the same as the decimal system I just showed you before. Right now, you're going to drop 1 out of 100 packets, 1 out of 1,000 packets, 1 out of 10,000. And I can even say 1 to 5 packets are dropped there as well. This is Gilbert-Elliott. This is the easiest way to describe to you what Gilbert-Elliott does. This is how our satellite companies use us to test partly cloudy. So you have your good condition when there's no clouds blocking the satellite receiver. Then you have your bad state where there are clouds blocking your satellite receiver. And we can toggle in between those gradually or sporadically, however you want. And then we have a bit error rate, which is scientific notation. Okay, and then we also have a network outage. This is, I could say, okay, every 10 minutes, give me a 30-second outage, right? So this is how our customers test like failover or application recovery. We have companies out there that do that have cache servers that are moving data from a cache server to a storage array, and they want to verify that their cache server can keep working after a network failure and then get back to proper speeds. They use this. You can also put ranges in this. So I can say, okay, every 10 to 20 minutes, give me 30-second to 120-second outage. Or we can be, if you're a satellite person, we can say, okay, every 1 to 5 seconds, give me, let's do it like this. Give me a 100 microsecond to 400 microsecond outage. So this is called flapping in the satellite jargon, I guess we call it. So those are kind of the 3 or 4 most important impairments we have. There's some others: corruption, reordering, duplication. Then we have background utilization, and then we can do a little bit with queue limit, queue strategy, and framing overhead, although in AWS they don't let us do much with that. But we can also do some jumbo framing stuff, so we can accept jumbo frames, we can fragment your jumbo frames. There are applications out there that don't know how to handle fragmented jumbo frames and they start failing. So you could test that using us. So that was a quick kind of 10-cent tour of the Netropy. So you see that we have created this environment. Now we could have multiple other JMeter servers and multiple other Apache servers on here, and we can add a bunch of other types of tests. So I'm just going to show you how easy it is to create some networks. Maybe I'll create a SATCOM network, and I'm just going to use the drop downs. The bad satellite network, I'm going to create that. Now I'm also going to create a 4G LTE if you want to do some cell phone testing, cell phone network testing, create that. So maybe I have a few other JMeter servers on here and more Apache servers, so I could just create more endpoints. So maybe I have, we'll say maybe it's a Neotis right? And he's plugged into port 1. Maybe you have many Neotis load testers. And so we could do something like 192.168.12.0/24. So now over here, you can have all of 192.168.0.24 can be on this side, and we can assign that to 4G LTE. All right, so now we see our Neotis load testers with this entire network. Anything that comes into port 1 that has an IP address of 192.168.12.x will be assigned to 4G LTE, right? And maybe it's going to backup web server. Port 2. And maybe his IP address is 192.168.13.13. And so maybe you have other types of load testers as well. And his their IP address is 192.168.22.0/24. So, oops, I put it on the wrong side. So here we have a situation where it's many to one, but we could do many to many. So you're only limited to 60 endpoints, but remember an endpoint could have, 255 machines on it. So this was a very fast intro to Netropy CE. If anyone has any questions, feel free to type them down below. We'll give you a second or two to add any questions there that we can answer. Jason, do you have anything to add?
No, that was great, Kate. I'm just really excited to be working with you guys and seeing where we can take this.
Right. Yeah, so what's really important about this is, with Heropa's technology combined with the Netropy CE, you can spin up test environments in the lab at a low cost, right? It's very easy to do. and you can get reliable results. And you don't need any special AWS skills. For example, if we were to create what we just created right now in a few minutes that you watched us do it, this would take even a really good AWS administrator at least a couple hours to create. But using Heropa to create the environment, and then using us to create the network within that environment, you get accurate results, you save money, and you don't have to be an expert to use it. So it looks like we got a question coming in. Does Netropy have previously recorded traffic emulation? For example, instead of actually having a web server, it will record the web server outgoing traffic and use that traffic to reply to a client. Okay, so yes, we get this question a lot. We are not a traffic generation tool. We have something similar to what you're asking for. We can actually record network events. So we can take a PCAP file, or we actually have a third party, our own freeware software called the Netropy Recorder that you can install in a real world environment, and that customer or potential customer or wherever that problem network is, you have them start the recorder and then recreate the issue they're having. And we record the network conditions that that end user was seeing. And then you can come in to this area and you can load that recording file in here, and then you can play it back. So it doesn't play back the actual traffic, but it can play back the network conditions. Apposite does have a traffic generation tool and a tool that will grab PCAP files and replay what you're asking for, and that's the Apposite load generation tool. So the Netropy doesn't do it. We have a different piece of hardware or virtual appliance that can do it. I hope that answered your question. Okay, any other questions? Okay, so the next question is, what is the maximum amount of networks the Netropy CE can, says configure, but I think allow. So you can have up to 30 different types of networks, or what we call paths. You can have 30 different types of paths, and you can have 60 different types of endpoints. So these endpoints can not only be, you saw me configuring with IP addresses, but you can do VLANs. So I could say VLAN 100 through 199. We can also do TCP or UDP port, MAC address, and this IP address can also do IPv6. Okay, so I think that's everything. So feel free to email us at sales@appositech.com. Jason, do you have a good email address to?
Yeah, sales@heropa.com.
Okay, great. So go ahead and check out the link we have on the screen for Heropa. It's heropa.com/free-trial. You can see the us in the Amazon Marketplace. There's the link there. I won't read it back to you. Thanks everyone for joining this webinar. Feel free to send us questions, and I hope to hear from you soon.
Thanks everybody.